A very good morning, children. Let's start our studies now. And our topic is relation and function. Chapter is relation and function, and the first topic is equivalence relation. At the end of this chapter, you will be able to answer these questions. What is an equivalence relation? What is an equivalence class? What is a one-one function, that is injective function? What is an onto function or a surjective function? What is a bijective function? What is inverse of a bijective function? And then how to compose two functions to obtain f of gx or g of x. Now children, before we start about equivalence relation, let's review what is an ordered pair and what is a relation. And then we come to a specific type of the relation which is called equivalence relation. Now, what is an ordered pair? As you know, an ordered pair is in general A comma B, where A and B belongs to R. For example, 2, 3, half comma minus 2. So ordered pair means pair of two numbers written within parentheses. And you have seen that in coordinate geometry, the coordinates in two-dimensional plane are given by an ordered pair. A specific location is given by an ordered pair. Now, before we review about the relation, we should know what is Cartesian product of two sets A and B. Cartesian product of two sets, which is expressed as A cross B, is nothing but collection of all ordered pairs. And how these ordered pairs are made? The first element should be coming from A, the second element should be coming from B. If we are going to find out A cross B. As an example, if A is 1, 2, 3 and B is 4, 5, then A cross B is obtained by pairing numbers. The first number will be coming from A, the second number will be coming from B. So it is 1, 4, 1, 5. It is pairing of 1 with 4 and 5, the elements of the second set. Then 2, 4, 2, 5, and in the same way 3, 4, 3, 5. So you can observe here there are 1, 2, 3, 4, 5, 6 ordered pairs. Number of elements, this is the symbol for number of elements in a set. These are 6 because each is paired with 2 elements and there are 3 elements here. So 3 2s are 2, that means 6. Hence we can say that number of elements in A cross B is given by number of elements of A multiplied by number of elements in B. Now, what is B cross A? B cross A, B element of B will be the first element in the ordered pair. Hence it is 4, 1. 4 will be paired with 1, 2, 3. 4, 2, 4, 3, 5, 1, 5, 2, 5, 3. In counting there are the 6 elements, but if you observe 1, 4 and here it is 4, 1. 1, 5, then corresponding to this you will have here 5, 1. 2 comma 4, corresponding to this you will have 4 comma 2. Now a ordered pair, the word order itself is telling that if the order is changed, then the ordered pair is different. Hence all the ordered pairs are of B cross A are different from A cross B. Hence A cross B is not equal to B cross A. So in general, A cross B is not equal to B cross A. A cross B will be equal to B cross A if and only if A is equal to B. A cross B will be equal to B cross A if and only if, means implies and implied by A equal to B. Both the sets are equal, then only A cross B and B cross A will be equal. So you can have two examples like R cross R, okay, and later we will apply Cartesian product of two sets to three sets. It can be extended to multiple number of sets. One more thing, if then element is there A comma B which is written equal to X comma Y, its meaning is that A is equals to X and B is equals to Y. Two ordered pairs are equal if and only if their first elements are equal as well as their second elements are equal. Then only we can say they are equal. Now, what is the meaning of A cross B cross C? As A cross B is set of ordered pairs, A cross B cross C will be set of triplets. Means there will be three elements, where A will be belonging to A, B will be belonging to B, C will be belonging to C. Its special case is R cross R cross R, where R is the set of real numbers, and this R cross R, which is the set of three numbers, is going to represent a point in space, and they are the coordinates, and so all the points of space. So this is indicating in coordinate geometry is three-dimensional space, 3D space. Whereas its special case is R cross R, that means set of all possible points in a plane, hence it is a plane. It is a two-dimensional plane. So this is all you studied in 11th class, and you also studied that a special word relation is used from one set A to another set B, indicated as R defined from A to B. Here, what is the meaning of relation from set A to set B? Basically, relation means, suppose A has some elements, say A is equals to 1, 2, 3, 4, and B has, suppose, 4, 6, 9, and relation is defined. Relation means there is a rule which will be making pairs or connecting elements of A to elements of B. So here the rule is that suppose X is belonging to A and Y is belonging to B, then X is connected to Y by rule R if and only if X minus Y or Y minus X, means difference of X and Y is an odd number. So this is implying that this R is basically set of ordered pairs which will fulfill this condition. Now 1 minus 4 is an odd number, so here 1 comma 4 will belong to R. 1 minus 6 is 5, that will also belong to this set. 1 minus 9 is 8, which is an even number, so it will not belong. 2 comma 4 will not belong because 2 minus 4 is 2, which is even number. 2 minus 6 will not belong, but 2 minus 9 is an odd number, so 2 9 will belong. Then 3 will belong to 4, 3 will belong to 6, but 3 will not belong to 9 because it is an even number. 4 minus 4 is 0, which is even number. 4 minus 6 is 2, which is an even number. 4 minus 9, which is odd number, therefore 4 comma 9 will belong to R. So you can observe here that basically R is containing these ordered pairs which are specific because the same rule is pairing the numbers of A and B. The first element is of A and the second element is of B. So it is subset of A cross B. Hence a relation is a correspondence from one set to another set, and it is subset of A cross B. It is specific subset of A cross B, so that in each ordered pair the same rule connects or associates elements of A to elements of B. So children, we have seen that here R is containing these ordered pairs. When we represent a relation in this way, then it is called algebraic representation, which is also called roster form of relation. This was obtained from the definition of R. R is given as x comma y such that the difference between x and y is what? X is belonging to A and y is belonging to B. A is coming from the given set 1, 2, 3, 4, and B is coming from the set in which elements are 4, 6, 9. This is set builder form of the given relation. It is also algebraic representation. So we can obtain this roster form from the given set builder form. One more way is there to represent a relation, which is visual representation, which is also called arrow diagram, in which the ordered pairs are connected by arrows. So 1 is connected to 4 because 1 comma 4 is there. 1 is connected to 6, 2 is connected to 9, 3 is connected to 4, 3 is connected to 6, 4 is connected to 9. So these are the points which are to be noted. If any ordered pair x comma y is there in R, that means x is R related to y, then y is called image of x under R, under the given rule, given relation. Domain means the set of first entries, first elements in the given R. If we collect the first entries, then we will obtain domain. If we collect the second entries 4, 6, 9, 4, 6, 9, so we will write without repetition, then we will get range. So in general way, domain is x such that x belongs to A, where x is related to y. Y is coming from set B. Similarly, range is second element y, which is coming from B, and x is related to y. Y is also called image of x. Codomain is always fixed, it is set B. And generally, relation is denoted by RS, etc., or R1, R2, etc. Children, before we come to equivalence relation, let us review two extreme relations. Observe here, the relation R is defined from A to B, where the condition is that A minus B is 10. Now since A is given 1, 2, 3, 4, B is 2, 4, and we cannot find any pair which fulfill the condition that A minus B is 10. That means it is the empty. This is called empty relation, and it is denoted by 5. On the other side, this relation S is defined in this way, where the model's value, absolute value of A minus B is more than or equal to 0. Now you know that absolute value is always positive or equal to 0. Hence, in this case, all the ordered pairs will be included. All the possible ordered pairs means 4 into 2, that is 8 elements, 8 ordered pairs. Hence, S is nothing but A cross B, the whole Cartesian product. Hence, this is called universal relation. So, these two relations together are called trivial relations. These are two extreme relations. Now, children, we come to specific relation in which set B is equals to set A. That means codomain is also set A only. So here R will be set of ordered pairs, but A and B both will be coming from set A. Here there is only one set. Codomain is also set A. Now this type of relation is put into three main categories, three main types. One is called reflexive, second is called symmetric, and third is called transitive. Now what is the nature of a reflexive relation? A reflexive relation is that relation in which necessarily A comma A will belong to R for all A. That means every element will be related to itself for every A. Symmetric relation will be that relation in which if A comma B is belonging to R, that means A is R related to B, then B will be related to R. B will be related to A. That is, if A comma B belongs to R, then B comma A is necessarily belonging to R. This type of relation will be called symmetric relation. And a transitive relation will be that relation in which if A comma B belongs to R, B comma C belongs to R, then necessarily A comma C will be belonging to R. That is, if A is R related to B, B is R related to C, then A will be necessarily R related to C. Now, we will understand these three relations, reflexive, symmetric and transitive, if we take few examples. But due to shortage of the time, example I will be taking in the next session. Till then, goodbye. Thank you.